In a recent year, the Better Business Bureau settled 75% of complaints they received. You have been hired by the Bureau to investigate complaints this year involving computer stores. You plan to select a random sample of complaints to estimate the proportion of complaints the Bureau is able to settle. Assume the population proportion of complaints settled for the computer stores is 0.75. Suppose your sample size is 138. What is the probability that the sample proportion will be at least 2 percentage points higher than the population proportion? So the sample proportion is p hat, and 2 percentage points higher than 75% would be 77%. So we want to know the probability that p hat is greater than or equal to 0.77. We're going to round any z values to 4 decimal places. So we only have one z-score to compute in this case, and we're going to use the same z-score formula we used previously. So we're first going to figure out how different is the sample proportion of 0.77 from the claimed proportion of 0.75, and then we're going to find out what's called the standard error of the proportion by taking the square root of our p, 0.75, times our 1 minus p, 0.25, divided by our n, our sample size, 138. And when we calculate that value, we get a z-score equal to 0.5426. So let's picture what we have here before we go and grab this probability that it's greater than or equal to that. We're in a normal curve, centered at the true population proportion, which is 0.75. Our sample proportion of 0.77 is only about a half a standard deviation above that claimed value. And we're wanting to know this probability that it's even greater than that. So our lower boundary is going to be our z-score, which is the 0.5426 that we just calculated. Our upper boundary is going to be all the way to positive infinity, and I typically have my students use the largest number that our calculator can deal with, which is 1 times 10 to the 99th power. And that's found by just taking 1 and then your second comma and then 99. And then, of course, whenever you're entering your normal CDF command using z-scores, then your mean is 0 and your standard deviation is 1. So normal CDF from 0.5426 to 1E99, again that's 1 second comma 99, with a mean of 0 and a standard deviation of 1, gives us a probability equal to, and that would be this tail area, 0.2937.